Hey grade 10s, so today we're going to look at the different properties of acids and bases. Okay, so some of the general properties of acids. So acids generally tend to taste sour, so if you think of tasting lemon, it's pretty sour and lemons are pretty acidic. Acids are also good conductors of electricity and they will change litmus paper red. So litmus paper is an indicator paper that we can use to see if something is an acid or a base. So if we had blue litmus paper, acids will change it to red in color. Acids also tend to be very corrosive, and that means that they can eat away at materials, even flesh. So the stronger the acid, the more corrosive. Some examples of different acids are lemon juice, vinegar, hydrochloric acid, and even aspirin is an acid. It's called acetylsalicylic acid. So the reason why acids are good conductors of electricity is because when they are released in water, so when you add water to an acid, they will release hydrogen ions. And so that will allow them to conduct electricity. Formulas for acids are also really easy to recognize because they always have hydrogen first in the formula. So H2SO4 is sulfuric acid, H2CO3 carbonic acid, HCl is hydrochloric acid, and H3PO4 is phosphoric acid. So I know those are all acids because they start with hydrogen in their formula. Okay, bases are different in their properties compared to acids. So bases, if you were going to taste a base, it tastes very, very bitter. Bases are also very slippery to the touch. If you think about like cleaners and soap, those are slightly basic and they're very slippery when you touch them as well. Bases are also corrosive. We call them caustic. So they will, like a very strong base, will actually eat through materials and eat through flesh as well. So if you think about like drain cleaner, when you put that down the drain, you're trying to break up hair and other organic materials that are in the drain. And so it will do that because it's a very strong base. Bases will change litmus paper to blue. So again, that litmus paper is that indicator to tell us if something is an acid or a base. And we can have red litmus paper as well. And if you dip red litmus paper into a base, the paper is going to turn blue in color. Bases are also good conductors of electricity. And some examples are baking soda, drain cleaner like I mentioned, soap, ammonia, which is another chemical that's found in a lot of cleaners, and antacids. So if you have heartburn or something, then that's a type of base that you might have come into contact with. So again, bases are good conductors of electricity, but they are good conductors for a different reason. When a base is dissolved in water, it's going to release the hydroxide ion, so those OH negatives. And that's going to make bases a good conductor. The formulas for bases are a little more tricky to identify. A lot of the times you'll see the hydroxide ion or the bicarbonate ion. So sodium hydroxide, magnesium hydroxide, those are good examples of bases. Sodium bicarbonate or baking soda is another base. It's got that bicarbonate ion in it. Okay, so the pH scale is an indicator of how strong of an acid or how strong of a base something is. So basically the pH scale is a numerical indicator of how acidic or basic something is, or if it's neither an acidic nor a base, if it's neutral. So the scale ranges from 0 to 14. Anything less than 7 is considered acidic. The lower the number, the stronger the acid. So for example, a strong acid would have a pH of 2. Anything higher than 7 is considered a base, and so the higher the number, the stronger the base. So a strong base might have a pH of about 12 on the scale. pH of 7 tells us that the solution is neutral. That means it's not an acid and it's not a base. It's a neutral solution. So for example, distilled water would be a neutral solution that would have a pH of 7. So this is just to show you kind of a visual of some different household compounds or things you might have come into contact with and kind of where they fall on the pH scale. So again, water is neutral at a pH of 7. Some acid examples: tomatoes, pretty acidic. They have a pH of about 4. Apples are between 3 and 4. Stomach acid has a really low pH. It's very, very acidic, less than 2. And battery acid has a pH of about 1 or less, so very, very acidic. And then on the other side of the scale, at a pH of about 12 is bleach, and then drain cleaner is between a 13 and a 14, so very, very basic. Okay, and the last thing I want to talk about is a neutralization reaction. So this is basically when we take an acid and a base as our reactants, and when that happens, they will neutralize each other. So the products that we get from that reaction have a pH closer to 7. So usually the products are a water and a salt of some kind. So for example, if we took sodium hydroxide and hydrochloric acid, so the sodium hydroxide is the base and hydrochloric acid obviously is the acid, the products that you get are water and sodium chloride, so salt. So that's what we call a neutralization reaction. So a salt in chemistry can mean any kind of ionic compound, so any kind of compound that has a metal and a non-metal. So neutralization reactions are a type of double displacement reaction that involves an acid and a base. So thanks very much for listening, and I'll see you in class.